and link management functionalities. And then the triple P supports error detection. It has features for error detection. And then establishing the network addresses. As we have already seen, the triple P no need to configure the IP address to be set before it is established. And coming to the authentication. Yes, it supports authentication and it can support two different protocols for authentication. So one is PAP, which is the password authentication protocol. It is a two-way handshaking protocol. And the second one is a CHAP protocol, which is the challenge handshake authentication protocol. And this is a three-way handshake protocol. So these two protocol helps to identify the client with the help of handshake process, and this authentication will happen at the time of the initial link establishment, and even this can even happen, the authentication can happen again at any time later also. So this is about the authentication. And coming to the next principle, which is extensibility. The triple P protocol defines a extensible LCP, which is link control protocol, a sub protocol that allows negotiation of an authentication protocol for authenticating its peer before allowing the network layer protocols for transmission over the link. So these are the design principles or the solutions to overcome the drawbacks of the SLAP protocol. And coming to the other points, yes, triple P is a layered, yes, it's a data link layer protocol. Also, it relies on another data link control protocol, which is the HTLC protocol for the basic operations. So, after the initial handshake process, triple P executes its own handshaking process. So, in order to perform that, it consists of two protocols, two sub protocols, which is the LCP and NCP. The first one is a link control protocol, and the second one is a network control protocol. We'll be learning about these things in detail. So, next, coming to the triple P state machine, what happens in the triple P? Initially, a handshake process will happen. So that is for the link establishment. So the source will be sending a request, and equivalently there will be a reply from the other workstation, and the link will be established. During this link establishment, how it has been established? So based on that, the triple P process can be written as a state machine or like a life cycle. So this state machine picture tells the overall process of the uh, WAN connectivity or the communication that happens with the help of the triple P protocol. So it consists of dead state, established state, authenticate state, network state, terminate state. In any of the state, if it is not a successful one, then it goes to the dead state. So that is if the established state is not success, then it goes to the fail state. Similarly, if the authentication is not successful, then it goes to the terminate state. Likewise, during the after the data transmission, also it goes to the terminate state. We'll learn about the definitions of each of these states. First, coming to the dead state. So, when the link is not at all used, when the utilization is not yet started, it is said to be in the dead state. And then establishing when any one of the workstation starts the communication, then the connection is said to be in the establishing state. And the third one is authenticating state. So we know that the triple P supports two types of authentication protocols, PAP and CHAP. So if any of the workstation or if the user sends the authentication request packet, and it is requesting for the client verification, then it is called as it is said to be in the authenticating state. And the fourth one is after authentication, when the communication starts, it is said to be in the networking state. And finally, when the user ends the transmission, when the link termination happens, it is said to be in the terminating state. So these are the various states of the triple P protocol. So as mentioned in this diagram, this various levels of things are happening